So let's go ahead and begin review. Please let me know which problems you would like me to do. You all have access to this document on Blackboard. Keep in mind that this exam deals with area between curves, disc and washer method, cylindrical shells, surface area, came after surface area. What's this? Can you post this video on Blackboard? Dan, I have been putting them on YouTube. Can you not access them there? Okay, Tom, I see you want me to do a differential equation. We can certainly start there. Let me just go over the rest of the material really quick. There's also work problems, so springs, leaky buckets, tanks that are being emptied. Arc length is one I forgot, so yeah, we have arc length and surface area. Making sure an equation works within a differential equation. Solve the following differential equations. So that's both separation of variables and integrating factors. And then there were some applications. The ones that we did were orthogonal trajectories and Newton's law of cooling. We skipped the mixing problems, so you do not have to worry about number 13. Hopefully everybody just heard me say that. So Tom, would you like me to do one of these problems here? If so, please tell me which one. And Dan, I thought I put the, where is it? I thought I put that up on Blackboard for you under the announcements. Yeah, under announcements it says YouTube channel. So if you click that, it should take you directly to my channel where all the videos are. You might have to do a little bit of searching because there are videos for all of my classes there. Alright, so I don't see... Ah, there we go. 10, yeah, I got that, but what... Do you care which one? Alright, 10B. So we'll do this guy. So let me just write it over here, and then I'll make the board clear so that we can solve this guy out. Okay. So let me add an extra page here if I can. That's clear. There we go. All right. Okay, so I've got a differential equation here. The first question is, which method do I solve with? So is it integrating factor, or would it be better to do separation of variables? So I think this problem, we can do separation of variables quite easily, and that's always the easiest one. In fact, integrating factor just breaks it down so that we can get to something that can be solved with that method. I see here that I can factor out a y. And then this is all a function of x. So let me come over here. This is really dy dx. And that equals 4x cubed minus 1 all times y. I'm going to move the dx to that side, move the y to that side. So dy over y is equal to 4x cubed minus 1 times dx. And then I'm going to integrate this on both sides. So integral of dy over y, that's natural log y. And the right-hand side, I can go ahead and, well, let me leave that there. Let me rewrite it this way, just in case you need to see it. So it's really that. So this is x to the fourth, right? Because it would be x to the fourth over 4. The 4's would cancel. Minus integral dx is just x plus c. So this is good enough for me to be called the general solution. You could easily solve this for y, but we need to get c. So let's go ahead and leave it here and plug in those values that were given. So I got y of 1 equals -3. So natural log. And here, this problem is actually really important. Remember that when you integrate this, you technically get absolute value here, which is very important for this particular problem because we're plugging in a -3. So it looks like we just get c equals natural log 3. So if we plug that back in and solve this now for y, we'd have natural log of y is equal to that guy there. And then we have to raise both sides e. And I'm actually going to write that e. So in case you were unfamiliar, e can be written as exp. You might see that in a paper somewhere or in a textbook. So exp of 1 is the same thing as e to the first power. I just want to use this notation because there's so much stuff there in the power. So this is y equals exp x to the fourth minus x plus natural log 3. That's good enough there. trying to think if there's a better way to write it. I guess as a technicality, we could write e to the x to the fourth minus x times e to the log 3. And that would be 3 e to this power. Be another way to write that. Any questions about that one? Yeah, I'm perfectly fine with that one. Any other questions about the process? Anything else? If not, please someone else feel free to suggest another problem. I'm going to go ahead and erase this guy. This is all we're expected to know differential equation wise for the exam. So differential equation wise, you need to know how to do a separable differential equation. You need to know how to do a integrating factor and possibly one application. I saw somebody say something about any factors that help determine which method is preferable. When you say preferable, there are only certain problems that can be done both ways. Otherwise, if the functions can be separated so that you can get all of x on one side, all of y on the other, right? So remember in class I did the f of x dx equals some g of y dy. If you can get it in that form, well, that's separable. If it's not, then it's got to be in this form. So dy dx plus some function of x, y equals some q of x. I think I saw somebody say do the area between curves. We can look at that one. The in-class assignment examples go into much greater detail. Sorry. There you go. So what did you mean by that, Tom? That I work out more detail, or no? Thank you guys for letting me know, or that you're just suggesting people look at the suggested homeworks. What are you asking or saying? when we're done, so I don't know if that helped. I think it was Brian that asked that question, so it's got to be in one of those forms. Those 4 are fairly easy regarding differential equations. I'm guessing we will be testing on something like those. Oh, okay, so you're saying that the other problems are a little harder. Can you give me one of the other problems then? I'll be happy to solve one of them. While you're figuring that out, let me go ahead and go back and do that area between 2 curves quickly. Because I can tell you that because it is a take-home test, it's not going to necessarily be a cakewalk, but it's not going to be super hard either. I mean, you guys already think my exams are hard, I believe. Alright, so let me look at this guy real quick, the area between 2 curves. Sorry, the camera's moving. My cat has decided to sit on the table. That has also resting the camera. Come on, kitty. Sit there. Okay. So compute the area between the 2 curves, the area pictured. So we need to find that point and that point in order to do that. The 2 functions are given, so the first thing we would need to do is set those 2 functions equal to one another. So let's say we get x cubed minus x squared plus 7x squared minus 7x if we move everything over to this side. Hella, come on, go. All right. This simplifies to 6x squared, so we got x cubed plus 6x squared minus 7x. Factor out an x. So one of the solutions is, wait, sorry, I'm doing part B, not part A. That's fine. We'll plot that one. Okay, so this is telling me one of my positions that they're equal is 0. If I factor this is x and x, so I need 2 numbers that multiply to -7 and add to +6. That's going to be +7 and -1. Those are going to give me then +1 and -7 as my solutions. So I'm off the board there. Let me move that. So we get x equals 0, -1, and +7. So these 2 functions look like they cross twice. And then we did one way back when in class like that. So to do the area between those 2 curves, we're going to have to actually calculate both of them. Let me go ahead and let me see if I can find my calculator quickly and plot them just so we know which one's on top. Yes, that's what I had, Ken. I think I had that the first time and wrote it wrong or something. I'm not sure. But you got video evidence now. There you go. So let me finish this one, Dan. And then if you really need me to do A, I can. But it's my guess is the only problem is you're having trouble getting the solutions to where they're equal, and then it's a very simple problem. And let's see. So we've got x cubed plus 7x squared. The other function is x squared plus 7x. If I graph them, I'm going to change my window. Of course, now I can't see the thing. Here we go. Alright, so the graph looks like this. And then we've got the parabola. Which I assume looks something like that. So it looks like the cube is on top from 0 to 1, and then the quadratic is on top from -7 to 0, and then from 0 to 1 it changes. So for the integral, you would do the cubic on top for the first part. So x cubed, let me scoot over, right off the board. You would integrate, you'd have x cubed plus 7x squared minus the quadratic function. And that would run from -7 to 0. And you would have to add to that from 0 to 1, the quadratic on top minus the cube. So I'll leave the integration for you guys. But that's the hard part, is solving for the points that they overlap and then setting up these two pieces. Alright, I see Dan says, my only question is, do you change it into terms of y? I see what you're saying. You do not need to do that. You can just do the, up here this would be the integral of sine x minus cosine x. And then you would just need to find your bounds. So you would need to find out, when does cosine equal the sine. And that should be at what? Should be pi over 4, I believe, there. And then this one, I think, is going to be 3 pi over 4. Maybe, let's see. Pi over 4. Yeah. Should be 3 pi over 4. I see some questions here on the chat. Let me just check and make sure I didn't miss anything. Come on. Tom, I saw you said something about having some questions about the differential equations, so yes, we could do another one of those. Sorry, 5 pi over 4. Yeah, you're right, because that would have to be, to get the 2 pi, I'd have to have 8 pi, sorry about that. Do we have to show how we get the bounds? Yes, I would like to see how you get the bounds. All right, so you say you don't have any personal ones, so let's go pull up the assignment really quick. You said that those seem like those are maybe a little tougher, so let's look at those. And while I'm pulling that up, if anybody has any other suggestions of problems they want to look at, please let me know. Cat has returned. I have to be a little more specific by the older problems. A lot of them are old to you now. It's been quite a while. $12 or $14, okay. You guys are awfully worried about what my cat is. My video keeps dropping. You said you were recording and we'll post this. Yes, it'll be on YouTube. Number 6. Okay, so I heard 12, 14, 6. And my YouTube channel is on, it's listed with on the Blackboard site in the announcements. Alright, let me just pull up the assignment. I don't remember which one it is off the top of my head. So those are all separation of variables. Did one of those, so let me go ahead and do one of the integrating factor ones instead. Abood, I don't know if there's extra credit. I see you keep asking me about it. You should probably be worried about the regular credit right now as opposed to the extra credit. Let's see. I'm going to go on a limb and say maybe 3 looks a little odd, so let's go ahead and try that one. And then I will go ahead and work the other problems that you guys suggested. So let me just jot this down at the top here. Y dx cosine x squared plus y minus 1 equals 0. Y of pi over 4 equals 2. Alright, so let me just go ahead and get that off the screen. Okay. So let's say I gave you this differential equation. You would think to yourself, well, can I separate it? Actually, I think you can. So let me just show you this. Let's see, dy dx cosine squared x. I could move these two terms to the other side, and it would look like that. I then could leave cosine squared over dx on this side, move the y or dy to the other side, like so. And then I could flip both of those fractions. So dx over cosine squared equals dy over 1 minus y. The integral of 1 over cosine squared, that's equal to secant squared. And integral of secant squared is what? Tangent, right? So we get tan x plus c integral over here. Let u equal 1 minus y. Du is minus dy. You put a negative in and a negative out. You would end up getting minus the natural log of 1 minus y. Dang. Sorry about that. And then if you wanted to solve for y, you could see where am I at here on the screen. Let me just turn the camera slightly. Let's see if I can pick up a little more of the screen here. There we go. All right. So if I want to solve that for y, raise everything by e. So e to the tan x plus c is equal to, actually this would be a negative up here. That'd be 1 minus y. So y equals 1 minus e to the negative tan x. And there's technically going to be a c1 in front of that e. So let me write that over here because it looks like it's really hard to see. I just wanted to do this one both ways and see how our answers look. So 1 minus C1e to the minus tan x. This looks like what we get out of doing it by separation of variables. So were you all able to see that okay, or do you need me to move over and do it again? Or if there's any questions about what I did, please ask now, because I want to do it the other method. Okay. So we already know what the answer should look like. Of course, it could come out a little different. Let's see. Now I want to do this using integration factor. So to do that, remember I said the form's got to have dy dx by itself, which means I'm going to first move this 1 to the other side of the equation and divide everything by cosine squared. So I would end up with dy dx plus y over cosine squared equals 1 over cosine squared. Now, of course, we all know that 1 over cosine squared is just secant squared. So let's rewrite it that way. So at that point, I need to find my integrating factor. Well, my integrating factor depends on this multiple here on y. That's my p of x. So I can solve for mu. Mu is equal to e integral secant squared dx. We've already figured out that that was tan x. Next step is to take that, the integrating factor, multiply by every single term. So tan x, or sorry, e to the tan x, dy dx plus, let's write it, secant squared e to the tan x times y, all equals secant squared e to the tan x. All right. So if we did this right, this side should collapse to d dx of e to the tan x, the integrating factor, times y. Which in fact it does, because this is dy dx, leave e alone, and then over here, integral of tan gives you secant squared, and then you get back e to the tan again. So this is good. And since we know that fact, we already know how this is going to turn out really nicely on this side. Right, so we've got secant squared e to the tan. Let me come back over here. Will you ask us to do a problem both ways on the test? Actually, I really like that idea, so and then don't think that I'm only saying that, you know, to torture you. I just like the idea of having you do a problem two different ways in case you can get the answer one way. You know what the answer should be for the second type. So if possible, I may ask you to do that, yes. All right. At this point, we got to take that dx, we got to move it to the other side. Integrate both sides. Will you need to prove the bracket portion on the test? If so, can you show us an acceptable proof? You do not have to prove to me that you can go from here to here. I just always say it because I need you to understand how you get from one to the other. And it's a very good proof to yourself that if this is not equal to this, you've incorrectly found your mu. So it's a way to save you from doing the problem all over again. Will all of your classes be posted on YouTube? So by all of my classes, you mean every time we meet? Then yes, that's the plan. All of my other classes that I'm teaching are also there, so you may see some duplicates, right, because I teach 2 sections of Calc 2. So I apologize for that. I'll try to distinguish. Maybe I'll start writing section 1 and section 2. Alright, so integrating both sides. This side's really nice. The integral and the differential just give me back what's in those brackets. And the right-hand side we've already done. Basically over here we said that if we differentiate e to the tan x, we get secant squared. So if we were to integrate secant squared e to the tan x, we'd get back e to the tan x. Plus a constant, obviously. Solve for y. Divide everything by e to the tan. That gives me y equals 1 plus c e to the minus tan x. Would you believe it? It looks like I've got the same thing, except here I've got a minus c1 and here I've got a plus c. That's all a matter of constants. Right, that c there would be a negative number when I solve it for that value, and this one would be maybe a positive. So these effectively would be the same thing. Again, I'm not going to worry about plugging that number in there. That's just some basic algebra to solve for C. If there's no questions about this guy, I will move on. Certainly we could do a work-related problem. Let me go ahead and see what those ones that you already suggested. Alright, so earlier you suggested 12, orthogonal trajectory. You also suggested 14. And verse 6. So how about we start with 6, since I see you guys are talking about work-related problems right now, so let's go ahead and do that one. So that one I may need to keep on the screen. Just scroll up here. Okay. Hemispherical tank that is 8 feet in diameter is filled with fluid waste that weighs 70.75 pounds. So this is rho, and 8 feet is my diameter, or my radius is then 4 feet. Find the amount of work necessary to pump the waste from the tank to ground level. We're assuming that the tank is currently at ground level, because it doesn't state otherwise. So I got a hemispherical tank. And recall that I need to take a slice. And in that slice, this guy has its own radius, which I will call, I guess, big R in this situation, since I called that one little r already. We know that the distance from here to the center of the sphere is that little r. And then I'm going to call the distance from the ground level down to my slice y. So Pythagorean theorem says y squared plus big R squared is little r squared. Then if I solve for big R, that's r squared minus y squared. R in this case, little r is 4. So that's just 16 minus y squared. All right, we need our work. Work equals our force times distance. Recall that force is rho, and because this is a volume, that's rho v. That v is specifically of a slice. So I'm going to leave rho plugged in. What is the volume of a slice? Well, this slice would be circular, so its area is pi big R squared, and its thickness is dy. But I also have to take into wait. Yeah, the ground is at the top of my picture. This is ground level. Yes, you can assume that whenever it isn't specified. Yeah, okay. Thank you for answering that. So rho pi r squared dy, and then I need the distance that it has to travel. Well, if ground level's at the top there, and I called the distance down from ground level down to the slice y, it has to travel a distance y. So now substitute in, sorry, this is r squared there. I need to substitute in r squared and integrate. So this is pi rho integral 16 minus y squared times y dy. Okay, so that is 16y minus y cubed in there. Integrating this is 16y squared over 2 minus y to the 4th over 4. That reduces to pi rho. Let me go ahead and get my bounds as well. If y is the distance from the top down, the total distance from the center of the sphere down to the bottom is the radius, 4 feet. So this top slice goes 0, the one at the bottom goes 4. So this is just going to go 0 to 4. Alright, so pi rho, and then this is really 8y squared minus y to the 4th over 4 from 0 to 4. So again, at this point it's just plugging in. If you guys are okay with it, I'm fine with stopping there. The second part of the problem, it's just asking you to take the answer that you get and divide by this number, right? Because that's going to be foot-pounds. This is foot-pounds per second, and they want to know time, so they want to know seconds. Specifically, they say hours, so at the end, you would divide by 3,600. So any questions about this guy or any other work problem? Right, the only reason that this one's strange is because of the spherical nature. A lot of the problems that I give you are rectangles or cubes, and the volumes of those are very easy to find. Right, it's length times width times the thickness of the slice, dy or dx, whatever you called it. So if there's no questions, I guess the next one that you guys asked for was 12 or 14, so I can do one of those. So first, actually, let me tell you, I don't have the test finalized just yet, but I would guarantee you there will be at least 2 problems where you're asked to find the volume generated. So those could deal with disc washer or cylindrical shells. There will be at least one work problem. That could be anything from... Thanks, Ella. That could be anything from the springs to tanks, those sorts of things. Also the center of mass concept that we went over. You should also expect at least one differential equation of each type. So at least one separable and one integrating factor. I may include an application. You can expect at least one arc length or surface area. I probably will not have you do both. And I guess maybe one problem that's just any of those topics. So anything that's on this review, you should expect at least. So let's see, I said disc washer, and the other, that's 2 problems at least. Diffie Qs, that's 4. Work 5. Surface area 6. So yeah, I'm going to try to at least make it maybe 8 problems. Any questions about that before I start solving another problem? Are you guys sure that you're good with, you know, the cylindrical shells and stuff like that? Because that's certainly a lot older than all this differential equation stuff that you guys seem to not like. Alright, so cylindrical shell. Alright, so let's do this one. I guess I'll just do A. Actually, I'll go ahead and do B. Let me do B. Let me make myself some space here. Come on. Alright, I guess there's just not going to be an in-between, so we're going to leave it right there. Give me just 1 second. I'm going to take my dog upstairs because she's whining. So give me just 1 second. I'll be right back. Why don't you guys go ahead and spend a minute or two trying to set this up, and then you can see if your setup is the same that I come up with. All right, so cylindrical shell. So let me pull up the chat here so I can see if you guys are saying anything to me. Doesn't look like it. All right. Volume 2 pi r times L. Let's go ahead and plot this thing. I always tell you guys I want you to plot it first. So let's see. Let me do it on my calculator real quick. No, it's a parabola facing downward. I want to get a good picture of it. All right. Looks like something like that. And from the graph, it looks like it touches at 1 and 5. Let's see if that's true. We got to prove it. So we would take the minus x squared plus 4x plus 5 set to 0. I could multiply through by a negative first off. Looking for two numbers that multiply to negative 5 and add to negative 4. That would be minus 5 and plus 1. And if we solve, we get x equal 5 and negative 1. Those are the numbers that I picked off of the graph, so that's good. That means those are my bounds. Okay. Now notice it says also bounded by x equals 0 and y equals 0. So guess what? That's another way of saying bounded by the x-axis and the y-axis. So it actually turns out I don't even need this part. So we got to make sure to read all of our instructions. So we're actually rotating this right here. And so that makes this bound 0. And it says to rotate it about x equal 9. So if that's 5, let's say 9's out here somewhere. So something like that. And I gotta cut a slice. That's where I get my shell from. My axis of rotation was 9. I need my radius, which is this length. We know that this distance is 9. And the distance between the axis and the slice is always x. So pretty clearly my radius is 9 minus x. So remember the volume for a cylindrical shell, 2 pi r times L. we just got done saying r is 9 minus x. L, or the height h, whichever one you want to call it, is the function. So our function was 5 plus 4x minus x squared. So at that point, we would just need to multiply that all out. And integrate. So before I do any of that, any questions about the setup? Actually, while you're answering that question, I'm going to go ahead and start writing this here. Alright, so only one person said that they didn't have any questions. I'm assuming everyone else is good. Again, at this point, it's just plugging in numbers. The solutions are given to you in the notes. Right now, I'm really concerned that you can set up the problem and get to here. Plugging in the numbers is, you know, college algebra stuff. So again, I don't see any comments, so I'm going to assume that you guys are good. And we can do another problem. We've still got about 25 minutes. Any other problems you would like to see? Okay. Find it ironic you guys want to see 14. Didn't we just do those last time, I thought? All right, so 14 is an application. So let's go ahead and do that one. Let me just make some space here on the screen again. All right, and pull the chat. Okay, so cup of coffee is poured from a pot that is 95 degrees C into a non-insulated cup in a room that is 20 degrees C. After a minute, the coffee has cooled to 90. How much time is required before the coffee reaches a drinkable temperature of 65? So, cup of coffee is poured from a pot of 95 degrees C. So, temperature at time t equals 0 is 95. Temperature after 1 minute is 90. The room that it enters is a temperature of 20. That's your T sub M. And finally, temperature of time T equals what results in 65 degrees. All right. So recall, we had the form derivative of temperature with respect to time equals the constant of proportionality K times Tm, I believe it's minus T. Let me just check myself on that real quick. Feel free to chime in if you think that's good. Pretty sure it's right, but I'd rather not make a fool out of myself here. Actually, I don't think I have my Diffie Q notes here. Alright. Nope, I got the TM and the T backwards. It's a good thing I checked myself. Alright. So T minus TM. Shoo. Long day. Alright. You can solve this either way you like. You can also, right off the bat, plug in, for our case, that Tm is 20. I'm going to go ahead and do this, I think, with integrating factor, because I think that's the one you guys like the least. This equate, you guys can still have a note card when you take your exam. So I won't put this on there. You can go ahead and make up a note card. But just try to be responsible and don't write, 200 pages. should be taking the test as though you were in class. All right. So to do this by integrating factor, I am going to multiply this k in and move the kt term to this side. Integrating factor tells me that this mu here has to be e to the integral of minus k dt, because that's what my differential equation is over here, dt. So I get e to the minus kt, multiply it through everywhere. I'm going to go ahead and throw this minus k in front. Once I'm at that point, the left-hand side of the equation should collapse to the derivative with respect to time of the integrating factor times temperature in this case. Right-hand side stays the same. Let's come over here. Take the dt to the other side. And integrate. You can also, prior to that step, check yourself, make sure that the derivative here equals this. If I leave e to the minus kt alone, take derivative of temperature, it's this. Derivative of e to the minus kt is minus k, e to the minus kt, and you leave temperature alone. So you get those terms, it looks good. I'm over here now, integrate both sides. Left side's always lovely because that integral is going to get rid of that differential. And I'm just going to get the brackets. On this side, I could pull that 20 out in front. I leave the minus k inside because that's going to be part of my du, right? If I let u equal minus kt, du is minus k dt. So I just get back e to the minus kt over here, plus a constant. And then I want temperature by itself, so divide everything by e to the minus kt. And I get that equation. And as you guys might recall, that's the equation we get every single time. The only difference is this number here, because that's Tm. So now I need to start using the conditions that were given. If I'm given one that has a 0 for the time, I should use it. So 95 equals 20 plus CE to the K times 0. That makes that go to 1. Move the 20 to the other side. And you get C. Once we have C, you can plug it back in. So now we have that the temperature T is 20 plus 75 CE, or sorry, E, not CE, to the KT. Then I would use this one here. So 90 equals 20 plus 75 e to the k times 1. Fantastic. All right, move this over, divide by that number, take the natural log, so k is equal to natural log of 70 over 75. Go ahead and calculate that for you. Come on, marker. That is approximately negative 0.06. Let's just say 0.069. I'm sure one of the questions you're going to have is, how do you know when to truncate it? Let's just say for the exam, if I gave you something like this, 4 decimal places. So once we have k, we can plug it back in. I would end up with temperature equals 20 plus 75e to the minus 0.069 T. That should be the equation for the temperature at any time T. Let's go ahead and solve this for T, little t. So this is T minus 20 divided by 75. Then we need the natural log of that whole thing. And then all times 1 over negative 0.09. Alright, so all I did was just solve this equation for time t. Alright, I subtracted 20 divided by 75, took log to get rid of the e, divided by that number to get t. So now if I want to know what's the time for it to get to 65, well, I can just plug 65 into this equation right here, and let's see what that is. So 65 minus 20 divided by 75, natural log, all divide by negative 0.069. Looks like 7.4. It says minutes, so that is minutes. So time would be 7.4 something minutes. Any questions about that application of differential equations? So I'm giving you guys a second there to answer. You had asked me the other day, what about the project in MATLAB? I was just going to say that I think maybe what I'll try to do is just give you 3 more quizzes than normal. I'll try to give you 23 quizzes. And the last 3 that I give you will just count as your project. So the first 20, I'll take the top 10. The last 3 will count as the project. How did you isolate T? With a lot of with a lot of algebra. So I did all the steps at once. You could do this by yourself if you like. First thing you have to do is subtract 20. Move it to that side. So then you'd have T minus 20 equals all of this. So to get the E portion by itself, you would divide by 75. Then to get rid of the E, you would take natural log of both sides. So you would have natural log of this stuff equals equals the power times T. And if you want T by itself, you would then just divide by that number in front. How will quizzes work and when will they start? So if you guys like, I'd prefer if you had all your time to study. I can give you a quiz today. We did the sequences in series already, so I can give you a quiz today and have you turn it in to me Friday. So they'll basically be the same idea, but I think instead of giving them to you at the beginning of classes, I'll give them to you kind of like a take-home at that point. I mean, you're already home, but it'll be due the next class kind of deal. But since you're preparing for a test on stuff that you've already been quizzed on, I'd rather give you a quiz, simple, easy quiz on the new stuff, and you can get it out of the way and study. So it doesn't look like there's any questions on this other than the ones that have already been asked. We've only got about 7 minutes. Any questions, any other problems that you want me to work out? If you, I graded your quizzes and put those up on Blackboard, the scores at least. If you want to see any more about those, then set up a conference with me and I can show you your paper and discuss it. So I feel like all I did for you was a bunch of differential equations today. Hopefully that was helpful, and I hope that you guys are good with all the other earlier problems. I'm going to go ahead and stop the recording.